Okay, so the next style of trinomial that we'll factor is one that has a leading coefficient. That's this number here, this leading value of a. So an example of that is something like 2x squared plus 5x minus 3, and you're asked to factor. So again, if I could find some way to get these two middle terms, I'd be set, and we could factor by grouping. So here's how I do that. First off, I look for a number that multiplies, or two numbers that are going to multiply to give whatever a times c is, whatever 2 times negative 3 is. So I'm looking for two numbers that multiply to equal negative 6, and then that add to give the middle number again, like we were doing before. So two numbers that multiply to give first times last, and add to give the middle. So we just saw negative 6. That was could be negative 1 and 6, could be negative 2 and 3, negative 3 and 2, or negative 6 and 1. If you get used to making that list, sometimes you'll be able to find the answer in your head fairly quickly, but if you can't, you'll almost never make a mistake when you write your list of numbers out. You'll never miss one. Right? So in this case, two numbers that multiply to give negative 6 and add to give 5 would be negative 1 and 6. So I rewrite. I've got 2x squared minus 1x plus 6x minus 3. And you can see that these two add to give 5x. So we factor by grouping. We look at these first two terms. What's common? Hopefully by now you're seeing that the x is common, and you can see automatically what's left over. As soon as you know one, leave a space, write the next one. So we've got 2x minus 1. Then ask yourself the question, what do you multiply 2x by to get positive 6x? And it has to be a positive 3. And it's usually going to be easy. 3 times negative 1, negative 3, yep, that works. So your common factor, 2x minus 1, doesn't matter whether you write it first. And your leftover bits, x plus 3. That could be your first factor if you want. Makes no difference. If you need to check it, you know what to do. Distributive property, those two get multiplied, these two get multiplied, look at what you get, and if it comes out to this, you've done the right thing. Now it's not all rosy. Sometimes they're a little bit more involved, and that's fine. Same process. Look for two numbers that multiply to give whatever the first times the last is, and add to give the middle. So in this case, we're looking for two numbers that multiply to give whatever 8 times 15 is, or 120. And those same two numbers have to add to be 22. So I'm going to make a little list, and I'll come back. So this list took a little bit more time to do. It's a little bit more exhaustive, but 1 times 120, 2 times 60, 3 times 40. All the while I'm trying to think, do these things add to 22? So no, no, no. 4 times 30, 5 times 24, still not happening. 6 times 20, ooh, getting closer, 26. 8 times 15, that's 23. 10 times 12, bingo. 10 times 12 is 120, adds to 22. If I hadn't made the list, I might not have thought of those numbers. On the other hand, they might be the first two I think of. So I rewrite 8x squared plus 10x plus, or 10xy plus 12xy. Doesn't matter the order. In fact, let me just change that order right now just to show you that it doesn't matter. So I could write plus 12xy plus 10xy plus 15y squared. If I factor by grouping, the 4x is common to both. Notice, number out in front. That leaves me with 2x plus 3y. This has to be the same. What do I multiply 2x by to get 10xy? Has to be 5y. Does 5y times 3y equals 15y squared? Yes, it does. So, common factor, 2x plus 3y. Leftover bits, 4x plus 5y. And there we go. I factored a more complex trinomial. And by now you know how to check. 2x times 4x, 2x times 5y, 3y times 4x, 3y times 5y, and you should get the same thing.